quickly.
Awesome.
Okay. I guess the best way for us to proceed is to just go through these. Hold on a minute. Let me make sure that I get everything so we can see it. I'm not sure I had Windows 10 last time we had a session, so.
No, yeah, it was Windows 7.
Yeah, or even Vista, I think is what I came off of.
Interesting.
Okay, you needed to start at 6, is that correct?
Yeah, the I, root 63.
Okay, it's I to the 63rd power. Let's talk about I. I is equal to the square root of -1. I squared is that squared, which is -1. I cubed is I times I squared, so that's minus I. You with me?
Yep.
I to the 4th is I squared times I squared. -1 times -1 is +1. Okay? Then it repeats after that. Everything after that. I to the 5th is I to the 6th is the same as I squared. I to the 7th is the same as I to the 3rd. I to the 8th is the same as I to the 4th. Okay?
Got it.
So the pattern here is every 4 it repeats. So the solution is to divide this number by 4. Whatever remainder you get, use the appropriate one. In other words, notice if I took I to the 6th and divided 6 by 4, I get a remainder of 2, right?
Correct.
So it's this one right here.
Oh, interesting.
Very easy. So
Okay.
I to the 63rd is what? The same as what? I to what?
So you would divide the 63 by 4?
That's all you ever have to do on this.
To be 15.75?
You don't care what anything except the remainder.
Okay, so then 0.75. So would that be or negative?
The remainder of 3. That's the problem with doing everything on a calculator, is sometimes it gives you the answer as a decimal instead of as a remainder. If I divide 63 by 4, it's 15 with a remainder of 3. They gave it to you as 3/4, okay? But you got to be able to recognize that that's a remainder of 3. In other words, it's better to just do it. I guess you can always, do you have a key on your calculator that switches that to a fraction?
It does, yeah. It's 63/4.
Okay. It's the numerator that's the key, the 3.
Oh, interesting.
Okay, because we're dividing by 4. In other words, the remainder is always the remainder divided by your divisor. So this is 15 3/4, and the number we only care about is that one. I don't care if it's 150 3/4. The numerator of the remainder is the only thing that matters. That makes it this one right here.
Got it.
So I to the 63rd is the same as I to the 3rd, which is -I. Be a little careful here. The way I've written it, it's pretty easy to mistake a 1 for an I.
Got it.
So, but the key are these 4 on the left. That's the only 4 you have to remember, and know that it repeats every time. So, what's I to the 502nd power?
Would that be square root of -1?
No. When you divide 502 by 4, what do you get for a remainder?
I don't know exactly. I get 251/2.
Do it on your calculator and then switch it to a fraction and then read the numerator.
251.
4 into 502 is not,
Yeah.
doesn't begin with a 2, it begins with a 1.
I guess my calculator's being weird.
The remainder is 2. 4 goes into 502 125 times and a half. In other words, what your calculator should have given you was 125.5. Converting that to a fraction gives you 125 and 1/2.
Oh, okay. That makes sense.
But it's not 1/2. Be a little careful here. I've just confused you. It's really, yeah, wow. You can't really do these on a calculator. In other words, you have to make sure the denominator of that fraction is 4. So it's really 125 and 2/4, right?
Correct.
Which means my remainder was 2. So you can't automatically use the numerator of the fraction. You have to make sure the denominator is 4, and then you can use the numerator.
Okay.
Okay? But the biggest thing, first of all 3-digit, 100 is divisible by 4, 200 is divisible by 4 perfectly, 300, 400, 500, all of those. So the instant I see the 502, I know the remainder is 2.
Got it.
Okay? And that makes it this one here. The answer would be -1. All right. What's the next one on your homework?
Let's see, it's number 15. So that is 3 minus I over 4 plus 2I.
Okay. Every problem involving multiplication, division, addition, and subtraction is easy except the division. Okay? In other words, number 11. When you're adding imaginary numbers, you add the real part, you add the imaginary part, just like you would think.
Okay.
When you're subtracting them, you subtract the real part, you subtract the imaginary part. So number 12, what's the answer to 12?
Would it be...
Subtract the real parts.
Oh, only like the real, only the imaginary.
Do both for me. I just want to make sure you can add and subtract imaginary numbers.
So would it be 6 plus 6I?
Yeah. So those are easy. This one is easy. Multiplying is easy. What you end up with when you do multiply is you do end up with an I squared term. Okay? And like I said, the key is every time you run into an I squared term, substitute -1 for it, because that's what it is. Okay? So multiplying is just like multiplying 2 polynomials together. You use FOIL, and then when you're gathering like terms, make sure that you convert that I squared to a -1. I honestly think we should do one of these.
Okay.
Let's just do it real quick, and then we'll get back to your homework one.
Yeah, no problem.
Multiply that times this. FOIL it. What do you get?
Let's see, 54, 12I, see, that'd be 72, negative 72I, and then negative 16I.
16I squared.
Right.
The squared, a huge part, because that means I can take that number and turn it into a real number and combine it with my 54. So what is negative 16I squared equal to?
Sorry, I'm a little lost.
Okay. I squared, remember what we did on the previous page? What was
Yes.
I equal to?
Negative 1.
Okay, so this is minus 16 times a negative 1.
So it'd be positive 16.
Correct.
Okay.
Now I got 16 plus 54. There's the real part of the answer. Then I got to combine my i's. Well, 12i minus 72i is minus 60i. So that's the answer. Okay?
Oh.
And the only thing different about multiplying complex numbers or multiplying a regular linear factor is you're always converting these I squareds to minus 1. And be very careful here that you don't make a very common mistake, which is to drop one of these negative signs. In other words, I needed both of those negative signs, and it turned into a positive 16, not a negative 16.
Right.
Okay. Now, let's talk about your problem here, which is division. That's the only imaginary number problem that's tough. Nothing else is tough. There really isn't anything else that should give you trouble with imaginary numbers. Now, division is not really division. The way we're going to solve this is we're going to multiply the top and bottom by the conjugate of the bottom, always. Always the way we solve division problems with complex numbers. Okay?
Okay.
And why we do that is because it turns the denominator, the bottom, into a real number. First of all, make sure that you understand that as long I can multiply any fraction by the number 1 without changing its value. Okay?
Right.
So I can always multiply top and bottom by whatever I want as long as it's the same.
Got it.
Very important concept. It's not like an equation. I can't do anything to the top and the same thing to the bottom. I wouldn't be able to square the top and square the bottom. That doesn't work. You cannot do that. Not an equation. If it was an equation, you could square the left side as long as you squared the right side. But when you have a fraction, you can only multiply by the number 1. Now, do the bottom first. I'll show you what happens. What do you get when you FOIL the bottom together?
You get 16. Negative 8i. And then 8i.
That's always going to happen. Those two terms are always going to cancel. And finally, what's your last term?
Okay. Sorry. Negative 4i.
Squared.
Squared.
Don't forget the squared. That's a key part of it. Because that's
okay.
what's going to allow us to turn it into a real number. Okay. Now, those two go away. What's minus 4i squared equal to?
Let's see. I squared is negative 1, so would that be positive 4?
Correct. So now we have 16 plus 4. There's our denominator. Okay. Now multiply the numerators together.
Okay, by foiling.
Yes.
Okay, so it would be 12.
Whatever you want to call it. I call it ET. Every term by every term.
Oh, okay.
And the advantage of ET is that it works for trinomials also, right?
Really?
In other words, if you think about FOIL only works for a binomial times a binomial. If you've got a binomial times a trinomial, FOIL doesn't work, but ET does. In other words, you're always multiplying every term by every term. So the numerator becomes what?
Let's see. That'd be 12 minus 6i minus 4i, and then positive 2i squared.
Okay, simplify that.
Let's see. It's going to be negative 10i, 12 minus 10i, and the I squared, I guess that's the only thing I struggled with, the I squared. I didn't really know that before, but that becomes a -1.
Just always plug that in. So yeah, in other words, always do it like this if you need to.
So would that be 10?
Uh-huh.
Minus
So now
I?
we got 10 minus 10i in the numerator, right?
Yes.
Okay. Now I can still reduce that. In other words, I can divide top and bottom by 10. So I get I get 1 minus I all over 2. See that?
Yes.
Okay. Now, why is this a better answer than what we started with? Imaginary numbers are a little bit like irrational numbers. You cannot give an answer that has an irrational denominator, right? This is not a satisfactory answer to a problem. You have to rationalize it, right?
Correct.
When you rationalize an irrational fraction, you do it by multiplying the top and the bottom by that, and it turns it into square root of 2 over 2. Well, the only thing we did is we moved our irrational number to the numerator, basically. These two numbers are the same. 1 over square root of 2 in a calculator will give you exactly the same as square root of 2 over 2. But this is the proper mathematical convention because you don't want irrational denominators. Same thing with imaginary numbers. You do not want imaginary denominators. In other words, this really was not a division problem. It was an irrational denominator or a complex denominator problem. And
now, sorry.
Go ahead. And the problem was to what I call realify the denominator. That's what we did, was we made the denominator real. Started out complex, we turned it into real. Now, we still have a complex numerator, but that's perfectly okay. It's a lot like irrational stuff. You can have an irrational numerator, you just can't have an irrational denominator.
Got it.
Okay? And so whenever you have a complex denominator, you're always going to multiply by the conjugate. Because when you multiply a complex number by its conjugate, it always turns real. This one turned into 20. Well, any complex number, if you multiply it by a conjugate, will become real. All right. Did you have a question? It sounded like you
It was just kind of a weird question, but every time you have like a division problem with imaginary numbers, you can use this method?
Always. In fact, it's the only method. I don't even know how to do this by long division. If you told me to do this, I'm not sure I'd know how to do it. And that's because you never do it. It's always about making the denominator real. It's not a division problem. In the same way that 1 over square root of 2 is not a division problem, right? Or let's say I had 3 over square root of 7. Looks like a division problem, but it really isn't. It's just a problem that needs its denominator to be made real instead of irrational, to be made rational instead of irrational. So it actually becomes a multiplication problem, and you get 3 root 7 over 7. So this is the answer. It wasn't a division problem. I never at any point divided anything. It was always a multiplication problem. Same with complex numbers, basically.
Interesting.
Yeah. So the only one that could possibly give you difficulty at this point would be that. How do I do that?
Well, would you start with 5 over the square root of -1?
No. In other words, I've got a complex denominator. So this looks like a division problem, but it's not. Because all I have to do is make my denominator real.
Right, so it would be multiplied by -1 over -1, or -I over -I?
Correct. I over -I is the number 1. So I can multiply this thing by the number 1 if I want. And that gives me -5i in the numerator and it gives me minus I squared in the denominator. Well, if I squared is minus 1, minus I squared is 1. So this whole thing turns into minus 5I. So this number here is the same as that number there. It's just this number over here is proper. It doesn't have a complex denominator.
Got it.
All right. Let's go back to your homework here. What next?
Number 16, the 2 plus I over 5 plus 6I.
Okay, perfect. Let's see if you can do this one all on your own.
Okay, so the first thing would be to multiply negative 5 plus 6I.
No? What's the conjugate of 5 plus 6?
Negative 5 minus 6I.
No? Only thing that changes is the sign between them.
Oh, so it'd be 5 minus 6I?
That's the conjugate.
Got it.
Like,
Okay.
that's the definition of conjugate. The conjugate of x plus 2 is x minus 2. The conjugate of x minus y is x plus y. In other words, the only thing you change is that sign in the middle.
Got it.
Okay. Now, since we multiplied the bottom by that, we have to multiply the top also. Now, whether you do the bottom first or the top, doesn't really matter. Let's do the top first this time.
Okay, so that'd be 10 plus or minus 12I. And then negative 6I squared.
Hold on. Make sure you do these in order.
My bad, sorry.
Don't jump around ever when you're multiplying stuff together.
Got it. 5 plus 5I.
Okay. The reason is that you might forget. In other words, if we do the last step third, we might forget the third step. And sometimes you got this kind of situation where you're multiplying 3 things times 3 things. Well, you have to be very careful here not to skip one. In other words, I'm going to multiply that by that, and then I'm going to multiply that by that, and then I'm going to multiply that by that. And I'm going to take the second term, do the same thing. And what I mean is don't jump around and get out of order. It's a recipe for forgetting one of them. Okay? So,
Got it.
Okay, what's the fourth term?
Negative 6I squared.
Okay. And the bottom, let's just do it before, and then we'll go back and simplify both.
Okay, so 25 minus 30I.
Now let me give you a hint. Yeah, the next term is going to be minus 30I, but it's going to be followed by a plus 30I. So no matter what these two terms are, they're going to cancel out one another. And the only other term you're going to be left with is the L of FOIL.
The negative 36I squared?
Yeah.
Okay.
In other words, you can save a little bit of time by doing it that way. Okay?
Got it.
Now, simplify the top. And let's start there. What does that equal?
6.
Okay, and add that to the other real part of the top, which is that.
16.
Okay, now combine your i's.
It's negative 7I.
Mm-hmm. And what's the bottom?
Let's see, 36 plus 25, 61?
Correct. Now,
okay.
There is a proper format for a complex number, and the proper format is a plus bi. Okay? Well, at the moment, that is not in the proper format. It's got a real denominator, that's nice, but it doesn't fit the a plus bi format. In order to get it into a plus bi, we need to separate these fractions. We got that fraction and we got that fraction. So what we really have here is 16 divided by 61, that's a, minus 7 divided by 61, that's b, times I. So that is official, proper format for a complex number. Now, whether your teacher needs you to take it all the way to this step or not, I don't know.
I don't think so, but I think we're going to get into that pretty soon.
You might, yeah. Just remember that the way you turn this answer, and you're always looking at answers that look like this, up here, okay, on the right. In other words, this is always what you produce when you have a division problem.
Right.
And so it's just a quick step. If you have to turn it into the a plus bi format, then just separate that into two fractions.
Got it.
And then pull that coefficient out. In other words, when it's in a plus bi form, you wouldn't even want to put the I there. Okay? Notice what a small change I made. That's not correct. That is slightly different than 16 over 61 minus 7 over 61 times I.
Got it.
Now, it's the same, but it's not the same format. In other words, this one at the very bottom is this format precisely. This one right here really isn't, because I got the 7i above the fraction bar. I want to know what b is. B is 7 divided by 61. Actually, a negative 7 divided by 61. With me?
Yeah.
All right. Let's go back and what's the next one you have?
Number 19. So the square root of negative 169.
Right. When you're doing, let's take an easy one for a moment. First step, always separate this into two things. Minus 1 and that. That's always the first step when you're taking the square root of a negative number.
Okay.
Okay. This I can replace with I. That I can replace with 4. So it becomes 4i. That's all you have to do on any of these.
So
the square root of negative 169, well, the square root of 169 is 13. So
it would be 39?
Yes.
Oh, okay.
But like I said, the way you always, if there's ever any confusion, you'll get used to it after a while and you won't actually have to write it like I said. But if there's ever confusion, always do that. And that's I. And that's 13.
Got it.
Okay. What next?
33. So 2i over 1.
Is that 1 plus I?
I think so. I have it here. Let me pull it up real quick.
I think I can blow it up a little bit here. Yeah, maybe not. Oh yeah, I just got to get a hold of my plug.
Yeah, I have it. It's yeah, it's actually 1 plus I.
Okay.
Is that what you said?
Yeah.
Okay.
All right. First step.
It would be times 1 minus I.
What's in the numerator?
The same, 1 minus I.
Okay. Multiply the numerator.
That would be 2i. Oh, interesting. Sorry, I was used to like there being binomials on the side.
Think of it like this.
Yeah.
Just distribute. Because all you're doing is distributing the 2i.
Oh. Okay. So then it'll be 2 plus 2i or minus 2i squared.
Right. And the denominator, see if you can do it this time without those two middle terms in it, because you know they're going to cancel. So the first
over
term,
1.
What's the last term?
Negative I squared.
Yeah. Now, simplify the top, beginning with that. Actually, beginning with that.
So that would be a 2?
Correct?
Okay.
I begin there because I want to put that, my number part, first.
Got it.
So it's 2 plus 2i, because I still have that 2i there.
Got it.
Okay. Divided by what?
Let's see. So if it's a negative I squared, would that be positive 1?
Uh-huh.
Okay.
Just always do it like this.
So over 2.
Just always do it like that.
Got it. Okay.
And then that gives you the 2.
Now, couldn't you simplify that further to just be I?
Correct. Well, not just I. How do you simplify that?
You would divide it by 2, which would be
by
one
top and bottom by 2. So divide the top by 2. What do you get?
You get 1 plus I.
Divide the bottom by 2.
You get 1.
There's your answer. And the beauty of this answer is it's in perfect format. It's in A plus BI format.
Got it. Okay, the next one is 34. So that's 5 over 2 plus 4i.
Uh-huh. Go ahead.
Okay, so it would be 2 minus 4i on both the top and the bottom. Okay, and then starting with the top, it would be 10, and then it would be a minus 20i, and then on the bottom it would be 4, and then minus 8i.
Hold on, you're multiplying.
Oh, my bad. Skip the two middle terms, and you're left with negative 16i.
16i squared.
Squared, my bad.
Just make sure. You can't afford to make that mistake. You'll definitely get the wrong answer, and you'll lose full credit on it. You won't even lose just partial credit.
Got it.
Getting the I squareds is the big part of these problems. Okay, now the top is, can't do any more simplification on that. What's the bottom turn into?
The negative 16i squared turns into a positive 16.
Okay.
And then 4 is added to that and you get 20.
Okay. Simplify.
Seems
like this is exactly the same problem we did earlier. But maybe the sign was different. But what can I divide top and bottom by?
Number 15, it's very similar to number 15.
Yeah. Because I remember seeing an answer that looked a lot like this. Maybe it was 10 plus. But what can I divide top and bottom by?
You could divide it by 2.
Biggest.
Or 10.
The greatest common factor. You always want the greatest. Notice that if I divide it by 2, I can still simplify it. In other words, you would lose credit on that answer because it's not simplified.
Got it. Okay.
You always want to divide by the greatest common factor, which in this case is 10. What do you get when you divide top and bottom by 10?
Would that be 1 minus 2i over 2?
Uh-huh.
Okay.
And as long as that's an acceptable answer, if I had to put it into A plus BI format, what would it be?
It would be 1 over 2 times, would it be, or no?
A plus BI format.
Okay, so then it would be plus...
Well, in this case, minus. When it's minus. Plus, what really is the minus is the B. Okay?
Would it just be minus 1 times I?
Yes.
Okay.
There's your answer in A plus BI format, B being a -1.
Got it.
A would be 1/2, B would be a -1.
Okay.
Okay? All right, what else? Boy, they got a lot of these kind, huh? And
yeah.
The reason they gave you all of these and not these, because the rest of these are so easy. In other words, adding, subtracting, and multiplying complex numbers is a piece of cake. Division is the only thing that causes some confusion with certain people. All right, what next?
That is going to be 35, which is 5 plus I over 3I.
Okay.
Okay, so the first thing would be to multiply it by -3I on both the top and the bottom.
Good.
And then you would multiply that, you would get -15I, and then minus 3I squared. And then on the bottom, it would be -9I squared.
Okay.
And then you would simplify
Yeah.
the -3I squared and the -I squared. Starting with the top, it would be 3, or minus 15I plus 3, or 3 minus 15I.
I prefer writing it like this, merely because I'm closer to the A plus BI format.
Got it. Okay.
And
So 3
I always put the reals on the left and the I's on the right. It would still be correct if you wrote it like this. Wouldn't be wrong. But if at some point you have to put it into A plus BI format, it's better to, might as well be halfway there, you know? And what does the bottom become?
9.
Okay, now simplify.
Would you divide it all by 3?
Correct.
So you get 1 minus 5I over 3?
Uh-huh. And in A plus BI format?
1 over 3 plus -5 over 3.
Yeah, well, we don't need the plus. We'll just write minus 5/3.
Okay, times I.
And the I is outside that fraction. And now that term is A, and that is B.
Got it.
In other words, at some point, they're going to talk to you about graphing these. And the way you graph an imaginary number is that's the real axis, this is the imaginary axis. Okay? And so what I'm going to graph, if I were to graph this bottom number, well, I would graph, there's the 1/3. And now I go to minus 5/3 on the imaginary axis. Well, we'll call that minus 5/3. So the point would be right there. That's how you graph an imaginary number.
That's pretty cool.
And it is, but you can also see why you have to have it in A plus BI format, because this has coordinates of 1/3, comma, minus 5/3, with this being the imaginary and this being the real.
That makes a lot of sense.
Yeah. What next?
Number 54, which is going to be, next page.
Okay. Let's see. Hold on, I might have screwed up. No. Okay. That's this page here, right?
It should be, yes.
Yeah.
Okay, number 54. So I think that is, 5 plus I squared over 3 minus I.
What's my first step going to be here?
Would you square the 5 plus I?
I think so, yeah. I haven't come across too many problems like this, but the only time I might not do that as the first step is if I had a 5 plus I in the bottom that was maybe cubed, or in other words, if I could somehow do something other than, there's nothing else I can do here. And starting like this doesn't help a whole lot because I still am going to have to multiply that 5 plus I by itself. In other words, I can't multiply 3 plus I times 5 plus I squared. I don't know how to do it. But if I expand that, then I can. Okay, so let's expand it first before we multiply by the conjugate. It's the new numerator.
25 plus I squared?
No. Remember, I'm not multiplying by the conjugate of this, so those middle two terms don't disappear. It's only if I was multiplying 5 plus I times 5 minus I that those terms disappear.
Okay. Yeah, for some reason I kind of just put the power of 2 with the I and the 5.
That's okay. Here, let me make sure you have something memorized that will serve you well. If ever I have any of these two things, I don't want to have to take the time to FOIL those. It's always a squared plus 2a times b plus b squared. And this one is always a squared minus 2ab plus b squared. Notice the similarities and notice the differences. Only difference is in this term right there. Okay? So if I'm multiplying, I'm multiplying 5 plus I times 5 plus I, use this one and give me an answer. 25, that's the a squared part. What's this part going to be?
Negative I squared, or I squared?
No. It's 2 times a times b. A is 5, b is I.
So 10?
10i.
10i.
Notice that if you were to FOIL it together, your middle term is going to be 5i plus 5i.
Got it. Okay.
Always. And that's why the only reason I tell people to memorize, I'm not really in a habit of telling people to memorize stuff that they can always figure out, because you only have so much space in your brain and you really don't want to memorize any more than you have to. The problem is that in all math, from what you're taking now through the math you'll take for the next 2 or 3 years, you have to do this so frequently, one of these two operations, that it actually is quite helpful to know this, to have it memorized.
Got it.
Okay? And I saw a very clever problem once that asked this. What is this number going to be equal to? 100 squared minus 2 times 100 times 99 plus 99 squared. I saw that problem on an SAT test. Well, even if you could use a calculator, I'll bet you half the people would get it wrong. But it was on the portion where you couldn't use a calculator. So what's the answer to that? If you can't use a calculator, what is the answer to that using this right here? What's A and what's B?
10?
No. What's A? If this is this, what is A?
Oh, 100.
Okay, what is B?
99.
Okay, what's A minus B?
A minus B is 1.
What's 1 squared?
1.
That's what this is equal to, is 1.
That's pretty funny.
Right, but it also shows you the value of knowing these two.
Yeah.
In other words, they not only want you to be able to multiply these two together using FOIL or whatever other means you'd use, but sometimes they want you to have, they give you this and they want you to know what that's equal to. Well, I know if I know this formula, I know that's a plus b squared and this is a minus b squared. So I can do problems like this without a calculator if I need to.
Got it.
Okay? So it's a lot of value knowing these two things. It saves you a lot of time. You don't have to FOIL stuff. You can just know that you're looking at an a plus b squared.
Got it.
All right, so what's the last part of this numerator?
Let's see. So we did the first one,
Square.
25.
Remember, you're not foiling it. You're doing it from the memory of what a plus b squared is.
Okay, so I'm looking for A.
A is
Right.
5. What's b?
B is I.
Okay, and this last term is b squared.
So 25, or I squared.
That's it. In other words,
Oh.
I foiled that, but I didn't foil it. I did it based on knowing that a plus b was equal to a squared plus 2ab plus b squared.
Okay.
Okay? And we still have 3 minus I here. So let's simplify the numerator. What's the numerator become?
Just I? Or negative 1?
Well, negative 1 can be combined with 25.
Oh, 24 plus 10I.
There you go. So there's our proper numerator. Here is still the denominator we started with, and now we can do it like a normal division problem. In other words, is all we did was we multiplied the top together to give us this problem here.
Got it.
Now what?
Divide by 3?
Remember, these are never division problems.
Oh, right. Multiply by the, by, my bad. Negative,
Conjugate.
or 3 plus I.
Okay. Now, the numerator,
Let's see. So,
72.
okay, 72 plus 24I.
Yeah, and these you always have to FOIL out. In other words, there's no simple formula because they're not the same thing. It's only
Got it.
multiplying something by itself that you can use one of those other formulas.
Got it. And then that would be 30I plus 30I.
Plus 30i. I got to have the plus sign there. I can't not use it.
And then plus 10I squared.
Okay. What's the bottom?
9 plus 3I. Or my bad. Ignore those. Last term would be negative I squared,
Right.
which becomes 1.
Right. But
So
always write negative I squared first
Okay.
before you convert. In other words, I think in general it's a mistake trying to do 2 or 3 steps at once in math. You're just asking for errors. That's the way all errors are made by most mathematicians, is they're doing too many steps in their head and they get a sign wrong or they do some mistake. Okay? Better to do it like this and then simplify. What's the top become?
Let's see. So 10I squared becomes a negative 1, so that's a negative 10.
Okay, combine it with the other real part of the numerator.
62.
Okay. Combine your I terms.
Plus 54I.
Correct. And what's the bottom become?
Bottom becomes, see that negative I squared becomes a 1.
What's the
Yeah,
bottom?
1.
What's the bottom become?
A 1?
No, that's
No?
1, but I've got to combine it with the 9.
Oh, 10.
Okay,
My bad.
that's all right. That's what I was trying to get out of you. Was to give me the whole number. Okay, now, can I simplify that?
Yeah, no. Yes?
Anytime you have all even numbers, you can always divide even numbers by 2.
Okay.
Okay? I don't know if I can divide it by 4, but I know I can divide it by 2. Let's divide it by 2 and see what we got, and then we'll see whether it's fully reduced or not.
Okay. So that's going to be 31 plus 26.
27.
Or 27.
5.
Over 5.
Okay. Now, 5 is a prime number, so it can only be divided by 5, and 31 cannot, nor can 27. So now I know I'm fully simplified.
Got it. Okay.
Okay? And then if I had to put that into A plus BI format, I'm just getting you a little ahead of the game here, because I'm sure you'll have to do that at some point.
It would be 31 over 5.
That's A.
Plus 27 over 5.
That's B.
Times I.
Right. Okay.
Okay.
And then I cannot simplify either of those. If I could, I would. In other words, if it so happened that this was 30 instead of 31, well, now I would turn that into a 6.
Oh, okay.
Okay, so you might still be able to simplify even though you couldn't originally. In other words, had this been my answer like that, well, I cannot simplify that any further. But when I put it into A plus BI format, now I can simplify that part. It becomes 6 plus 27 over 5i. So sometimes where you couldn't simplify in this format, you can once you put it in A plus BI format.
Got it. Okay, next one is 55, which is 6 minus I.
Yeah, hold on a minute.
Oh, okay.
We've only got 5 minutes left. Let's not keep doing problems I know you know how to do.
Okay.
Okay? What's the next one after 55? In other words, I'm seeing some down here that look a little different. 58. Let's work on 58 with our remaining time.
Okay.
Does that sound better? I mean,
Does.
I don't mind you having numerous problems of the same kind, and I'm going to write this like that. Okay? The only reason they write it like that is the danger in writing it the way I did was that people will misinterpret and think the I is under the radical sign. Okay?
Got it.
So if you're going to write it like I do, make sure that I is outside of the radical sign, and you don't even want to have anything like that. In other words, that's confusing right there. So make sure your I is fully outside the radical sign when you do have one. And I'm going to do the same thing here. Okay. Now, what's my first step?
Multiply by the
by the conjugate.
Conjugate?
I think if you remember that name, it'll help you. In other words, sometimes it's irrelevant what the name of it is. And that's also the way I feel about most things. You know, I don't care if it's an isosceles triangle. What I care is that two sides are equal and that the opposite angles are equal. But in this case, words like conjugate are helpful, I think, in telling you what the first step's going to be, if you can remember the word that it's called. So what am I going to do here?
4 minus the square root of 2i on both the top and the bottom.
Now do the top.
Okay, so that'll be 16.
Using that formula, what is A minus B quantity squared? And you'll notice this is an A minus B.
A minus B.
So I'll write it for you because I in case it's always 2ab plus b squared, because that last term is always going to be minus b times minus b. Okay, so let's solve this problem by using this formula instead of foiling it.
Okay.
So a is 4, so a squared is 16. What's 2ab?
So that be 16 times the 2i?
2ab, let's write it out. What's a?
4? Oh, and then b would be negative 2i? Square root of negative 2i?
That's b.
Okay.
Okay, and then the last term is b squared. What's square root of 2i times square root of 2i?
I don't know.
Well,
Square root of 2i times the square root of 2i?
what's square root of 2 times square root of 2?
Square root of 4?
Well,
Which
square root of anything times the square root of the same thing is the thing.
So 2?
Square root of 17 times square root of 17 is 17. In other words, you don't want to actually multiply these two numbers together and then try to figure out what the square root of it is. Just know that the square root of x times the square root of x is equal to x.
Got it.
Okay, which means the square root of 2i times the square root of 2i, well,
This is 2i.
it's 2i squared.
2i squared.
Yeah, in other words, you have to multiply the square root of 2 times the square root of 2, but you also have to multiply the I times the I.
Got it.
When I got A times B times C times D, I can multiply them in whatever order I want, but it's all going to come out to be that. So that's 2i squared. That's what b squared is. Now the bottom is what?
Let's see. 4 times 4 is 16. And then would that be just plus or minus 2i squared?
Yes. Very good. Now simplify the top. Starting here.
Squared, it's negative 1, so that'd be 16 plus 2.
Minus 2.
Or minus 2, which would be 14.
Okay.
Over...
Hold on. You didn't give me that term.
So that'd be negative 8 times the square root of 2i?
Just like that.
Okay.
Okay. The bottom, it becomes what?
Let's see, the bottom becomes negative 2i squared becomes negative 1 times negative 2, which is 2.
What's the bottom become?
2 plus 16?
18 being the number that I want.
Got it.
Okay. Now, can I simplify that?
Yes, because it's all...
They're all even numbers. In other words, I can divide top and bottom by 2 at least. Let's do it.
Got it. Okay. So 14 divided by 2 is 7. Minus 8 divided by 2 is 4. 2 divided by 2 is 1. So would that just be...
No. In other words, when I divide that by 2, I only have to divide the 8 by 2.
Oh, okay.
Right? In other words, if I had 4 times 6 times 8, and I divide the whole thing by 4, well, I only have to do it once. I don't have to divide all 3 terms by 4. as long as these three terms are all being multiplied together, which 8, root 2, and I are, then you only divide that number by 2.
Got it. Okay.
What's the bottom become?
9?
Okay. And I can't simplify anymore. 7 is a prime number, so nothing divides into 7. Now, if I convert it to A plus BI format, I still can't reduce it anymore. And incidentally, that square root of 2 goes right there.
Got it.
This numerator, in other words, B is minus 4 root 2 divided by 9. That's what B is when I'm talking A plus BI format.
Awesome.
Okay. Well, that should be most of what you were given, I would think.
Yeah.
All right. Well, that's complex numbers in a nutshell.
Awesome.
And,
sure as well.
Well, you'll notice the thing you're always doing is converting I squareds to real, right?
Yeah.
We never ran into an I cubed, although if we look at 56, we can see we are going to have an I cubed. If you look at 56, at some point I'm going to have to multiply that I times that I times that I, and I'm going to end up with an I cubed. So you do have to know how to handle i's other than I squared and I. Remember that I cubed is I squared times I, so it's negative I.
Got it.
And you would want to make that conversion if you came across an I cubed. You'd want to turn it into minus I. Because then it could be combined with other i's that you might have. In other words, we're going to, in number 56, we're going to have a lot of i's also. So whatever I cubes we end up with, convert them to minus i's and then combine those i's with the other i's you have.
Got it.
Yeah, it's too bad actually we didn't do one of those because that is a little different. Just always remember those first 4 things that I started with. What I is equal to, I squared, I cubed, and I to the 4th. Those 4. You want to always know what those 4 are.
Got it.
All right, Connor. I will let you go and have a good rest of the weekend, what is left of it, and a good weekend.
Yeah,
I'll talk to you next time.
Awesome. Thank you.
You're welcome.